Hey everybody, it's Ripley. I'm back again. We're in section 7.6. We're going to talk about sum to product and product to sum rules for trigonometric values. In other words, if I want to take something like this, if I want to do sine alpha, sine beta, all right? So I've got a product of the sine of two angles, and I want to turn this into something that has a plus in it, or more importantly, the other way around. We'll use that way more often than the product to sum, but it's still good to see how it works. Or let's say that I've got cos alpha, cos beta, and I want to turn that into something with a plus. Or if I have sine alpha and cos beta, and I want to turn that into a sum. So I'm taking a product, excuse me, and I'm turning it into a sum. Now, check this out. It is so not hard at all, and it's taking an algebraic derivative of something that we've already done. Now, I know derivatives usually conjure up images of calculus, but we're going to simply use algebra and trig to prove one of these, and then the rest fall out pretty easily. So check it out. Let's just do the cosine of alpha plus beta and see what happens. We know from our angle sum formulas that this just turns into cos alpha, cos beta, minus sine alpha, sine beta. And then if I take cosine of alpha minus beta, this is cos alpha, cos beta, plus sine alpha, sine beta. Now we've already done this trick before. Do you notice that if I simply take these two equations and I add them together, if I add them together, notice that the sine alpha, sine beta just goes away. All right, so they just cancel out. So what does that tell me? Well, it tells me that I end up with cos alpha plus beta plus cos alpha minus beta is equal to, well, this plus itself is just 2 times cos alpha cos beta, and then just divide through by 2, and I end up with 1/2 times cos alpha plus beta plus cos alpha minus beta equals cos alpha cos beta. All right, now that takes care of this guy. Now, excuse me, what if I wanted to solve for this guy? Well, check it out. If instead of adding these two things, what happens? I'm going to change the color of my pen here. What happens if I subtract? Well, if I subtract, these two guys go away, and I end up with cos alpha plus beta minus cos alpha minus beta. Excuse me. Minus, where are we? Cos alpha minus beta. And then watch what happens here. Okay, so if I subtract the bottom from the top, these two are going to cancel, and I end up with minus 2 sine alpha sine beta, right? Divide through by -2, and what I end up with is 1/2. Now remember, when I divide through by a negative, the direction of this subtraction changes. So I end up with cos alpha minus beta minus cos alpha plus beta, right? And that equals sine alpha sine beta. Now, think about what you might want to do to figure this guy out. Now, I'm not going to do it, but think about, is there a sum and difference formula that produces a sine alpha cos beta? Or really a sine beta cos alpha? Either way, it doesn't matter. Basically what they're saying is alpha and beta are two separate angles. I've got a product and I want to turn it into a sum. If instead of using these two formulas, you use the sine of alpha plus beta and the sine of alpha minus beta, guess what you get? You're going to end up with the last formula, which is just sine alpha cos beta. And this guy ends up being 1/2 times sine of alpha plus beta plus sine of alpha minus beta. I don't want to bore you with going through this, basically the exact same algebraic details, just using a different formula. Okay, so that is product to sum. Again, all I'm doing in these last few sections is I'm filling up your toolbox, saying, hey, here's some tools. Here's some tools. Now, in the next section, I'm actually going to go say, hey, go build a house. All right? And what we need to learn next, rather than just these three product to sums, what we really want to be able to do is go from sums to products, which I'll show you here in just a sec, okay? Okay, now the question is, what happens, I'm going to change the color of this pen, this is a little obnoxious. What happens when I have sine of alpha plus beta? Okay, now I'm going to, whoops, sine of, I know what sine of alpha plus beta is. What I want is the sine of alpha plus the sine of beta. Sorry about that. So sine of beta, duh. All right, now think about this from an algebraic standpoint. Remember in algebra, I'm going to put this in right here. In algebra, if I've got two things that are multiplied together that equal 0, then I can set them individually equal to 0 and solve, okay? But the problem is if I have the sum of two things equaling 0 or the sum of two things equaling something else, I'm kind of screwed. This is called the zero product property, and we use it over and over and over again in mathematics. And that's true in trigonometric equations, which we're going to get into in the next section. Okay, so what I'm going to do is I'm going to give you this formula, and then I'm going to prove it for you. Okay, so I'm going to have 2 sine of alpha plus beta over 2 times the cosine of alpha minus beta over 2. Now, I am not going to ask you to memorize these formulas. Let me be very, very clear on this. I'm not going to ask you to memorize these. What I am going to ask you to do is to be able to reference them. Now, when I prove this, I'm going to do the proof over here. When I prove this, I'm actually going to, because this is an equal sign, I can prove it from either side. Basically, think of it as a trigonometric proof as being an identity. I'm just going to prove that this is an identity. And I'm going to start on the right-hand side. We're not afraid of that. We've done this before. Now, excuse me. What I'm going to do is, let me change the color of my pen. I'll show you this. I think you'll like this. I instantly notice that right here is a product. And it's a product of a sine and a cos where these angles are different. Now, they're not that much different, are they? It's a plus b over 2, excuse me, alpha plus beta over 2, and alpha minus beta over 2, but they're still different. Now, this is going to get a little bit confusing. So I'm going to just change this up, and I'm going to turn this into an x, and I'm going to turn this into a y, because otherwise we're going to get so screwed up with our alphas and our betas. Now, watch. I'm going to use this formula right here, this one. I'm going to use the product to sum formula, because remember, I'm trying to prove that this thing right here is an identity. And I notice that there is a sine something, cosine something different. Sine alpha, cosine beta, which is really just sine of some angle, cosine of a different angle. So that's what I'm looking at. So all I'm going to do is I'm going to plug this chunk right here in. Now it's going to get a little tricky, so bear with me. All right, so this, I know that this guy right here is equal to, now this 2 is just along for the ride. Watch what happens. 2 times, now according to this formula, sine times cos of different angles is this guy. So this is going to be 1/2 of the sine of, now alpha plus beta, so I need to take alpha plus beta in this, but I'm calling this x plus y. Okay, so I'm going to keep it real simple to begin with. It's going to be the sine of x plus y, because I've renamed those. Now you may say, Ripley, why the heck did you just rename those? Oh, by the way, I need another set of parentheses here, because this is half times all of this. All right, plus the sine of x minus y. I'm just keeping it simple. Sometimes I'll do an extra step just to stay out of my own way. It just makes more sense. Now, notice already, my 2's cancel, which is nice, because remember, I'm trying to prove the right side equals the left side, and the left-hand side has neither a 2 or a half. So when those cancel, at least I think I'm going in the right direction. Okay? Now, remember what x and y were. Now, if you're one of those people that there's just too many variables floating around, this is freaking me out, what you might want to do is just sort of on the side somewhere, I'm going to change colors, so we're kind of out of our own way. I'm going to figure out what x plus y really equals. X plus y, since this was x right here, that's what I'm calling x, and that's what I'm calling y. That's just alpha plus beta halves plus alpha minus beta halves. Hey, that's common denominator. My betas cancel. I end up with 2 alpha over 2, which is 2 alpha over 2, which is just alpha. So wait. Okay, that's cool. So watch what happens. What I end up with is sine of alpha, right? Let's see what x minus y is. Now, some students will go, Ripley, you're making it too complicated. I totally agree with you. If I were doing this, I probably wouldn't inject these extra steps into it. But some students really struggle with way too many variables floating around. I'm just trying to distill it down to very small parts that are relatively simple. Okay, x minus y is alpha plus beta halves minus alpha minus beta halves. Now you got to be careful here. I'm going to turn that into a plus, make that a minus, and that a plus. Now what happens? Alphas go away. I end up with 2 beta halves, which is beta. Hey, look at that. And I end up with sine alpha plus sine beta. All right, it's just another trick I did, you guys. I just did a little trick right in the middle of it. So that's my first sum to product. Now the other ones are just easy. They fall out the same way. I don't mean to be presumptuous in thinking that they're going to be easy for everybody. So sine alpha minus sine beta is equal to 2 sine of alpha minus beta halves. Put those in parentheses. Cosine of alpha plus beta halves. Okay, I could prove it exactly the same way. I would just need to go and find the one that's got a sine and a cos in it right here, and you would notice that something would happen there. All right, and then let's see, cosine of alpha plus cos beta, and in this case, this guy is going to be 2 cos of alpha plus beta halves, and then cosine of alpha minus beta halves, cosine of alpha minus beta halves. And if we had to prove this, and you never can tell, wink, wink, nudge, nudge, I might throw this to you on a test as an identity and say, prove it. Well, that's easy to do. Look at this. I've got it sitting right here. I've got a cos alpha, cos beta. In fact, because of my proof, I've actually got a 2 cos alpha, cos beta, if you can remember that. So if I had to prove it, I would use probably this piece of information and then just directly substitute. And then last but not least, I've got cos alpha minus cos beta. And then I end up with negative 2 sine of alpha plus beta halves. That's supposed to be an alpha, by the way. Sorry about my lousy handwriting. And then sine of alpha minus beta, excuse me, halves. And that's it. Look, I've got sine alpha plus beta, plus sine beta, sine alpha minus sine beta, cos alpha plus cos beta, cos alpha minus cos beta. If we have tangents, secants, cosecants, and we just pull them out of the secant form, stick them in a cosine form, pull them out of the cosecant form, turn them into sine forms, etc., etc. I mean, we've done enough of this by now. Now, again, this section goes really, really quick. I just wanted you to see the proofs of it and sort of be able to walk through it if you need to. Okay? Otherwise, we're just going to use them tomorrow in class, and I'll show you how to do that. All right? Hope you enjoyed. Have a really good day, and I'll see you in class tomorrow.